Hello, lovely students. Welcome to this video series on functions. It's topic 2 of the IB Math, SL, and HL syllabi, applicable for all of the AI and AA students tuning in. Throughout this video series, I'm going to be covering some basic and fundamental material that I think you should know getting ready for IB exams, as well as later on covering some worked examples from old IB exams, both for the SL and HL curricula, to make sure we set you up for success when you take your exams, whether it's this upcoming year, next year, or whenever you're listening to this video. In this topic, we're going to cover the basics of the domain, range, and asymptotes of functions. Nice and easy, but there are some caveats that we'll discuss. Let's start with the domain. Putting it super simply, the domain of a function is basically just all possible x values that a function can have so that it doesn't break, so that we don't break any kind of fundamental rules that we learned probably a long time ago when you're first starting your math trajectory out. I often like to refer to these as the forbidden values. It's a bit of a cliche, or maybe it sounds a little bit weird, but basically just ask yourself what x values is the function allowed to have and which ones can it not have. Let's just take some examples to make this make a bit more sense. Look at the function f of x is equal to 3x plus 5. You might be thinking, ooh, I recognize this kind of format. It's a linear equation with a y equals mx plus b kind of shape. It's really good if you recognize that, and if you don't, that's okay. We'll get to that later. But for now, if you look at this, basically what this says is this function takes in a value of x, it multiplies that value by 3, a coefficient, adds 5, a constant, and it spits out a new number. The question you ask yourself about the domain is, well, are there any values that are kind of off limits? And just by inspecting it, looking at it, you think, actually, no, everything seems to be pretty fair game. X can be a really big number, a really small number, a really small negative number, a really big negative number, 0. Everything kind of works. So in this case, we would say that the domain of x is all real numbers. Usually using that notation, x, an epsilon, it's a Greek letter, just means all or encapsulates all, and the capital R tells us that it's all real numbers that are okay for this function or a part of the domain. We can even inspect this graphically or show that the graph, this makes sense. This function is represented by that equation or that line. It's nice and straight. There are no breaks. There's no weird kind of deviations going on. All x values, at least what we can see in this small scale, work. We're led to suspect, or we can think it's probably pretty good for all values of x. Let's take a different example though, which is not entirely the same case. This new function, f of x is equal to 1 over x plus 2. We've got a fraction here, and fractions are important because a long time ago, when you were a wee little lass, you were probably told that you can't divide things by 0. Dividing things by 0 just doesn't work. Calculators will say that it's undefined. We break a bunch of mathematical properties. So divisions by 0 aren't okay. And in this particular function, the x is underneath the fraction, or it's in the denominator, which means that for a certain value of x, that denominator is going to be equal to 0, and that's off limits for us. In this particular case, we know, well, there's an x plus 2, so if we take away 2 from that 2, we get a 0. That means that if x is equal to negative 2, that function is going to break. So for this particular function, the domain is all real values of x, except x cannot equal 2. That's off limits. It's not part of the domain. If we look at the graph for this guy, we're going to get to later on how to actually graph these slightly trickier ones later, so don't worry. But if you just check out the graph of this, you'll see that right around x equals negative 2, it seems the function does some weird stuff. It shoots up to the top, shoots down at the bottom, and it never actually gets to a point where x is equal to negative 2, which is exactly what we just said. So domain, x can be equal to negative 2. Nice. We'll get to what that kind of weird behavior of the function is in the asymptote part later on, okay? So stick with me. How about the range? Really similar. The range, like the domain, is all possible y values or outputs that a function produces based on the domain. So based on what the x values are pumping into the function, what are all the possible y values that are spitting out? They basically go hand in hand. Let's take those same exact functions and see, well, okay, we know what the domains are. What exactly happens to the range in those cases? So for that same kind of linear equation, 3x plus 5. X is equal to all possible real numbers. Similarly, we would say, well, the y values, the range is also all possible real numbers. As x gets really big, the y values also get really big. As x gets really small, they get really small. So the net effect is, well, it's also all real numbers. Easy peasy. And we also can see this using that same graph. As x increases, y increases. As x decreases, y decreases. Same range and domain are both all real numbers. Let's look at that same function now that we looked at earlier, the fractional kind of function where the x is in the denominator. We already got the case where the domain for the function was already a little bit weird, that x wasn't allowed to take on a value of -2, so x could be all real numbers except -2. And we would suspect that something weird might happen to the range for this one as well. And I think the best way to look at this one is let's just graph it or look back to that same graph we saw earlier and see kind of what happens to all the y values. Noticing here that the y values are again on this vertical axis. So when we're around this -2 area, we see something pretty interesting. The y values can be really, really big, and they eventually decrease down and kind of have this weird little curvature inflection point until eventually they start to plateau out. Same thing, it starts really negatively big at the lower end of the spectrum, and eventually as x gets more and more negative, we start to see that kind of curvature. Notice what happens to the y values though. As x starts to get really big or really negatively big in the opposite direction, the y values never quite touch the x-axis. So y is actually never going to quite touch 0. It's never going to have a value of 0. We're going to explain why this is the case when we cover the asymptotes in the next few slides. But for the time being, we can see that in this particular case, the range of the function is one such that y can be all real numbers except not 0. It's never going to quite get there based on how this function is built and based on the kind of values that x pumps into the function. So we have, again, the domain, all the x values, and the range, all the y values that can come up as a response to those x values that come into the function. Let's briefly chat about asymptotes, then we're going to go in the next video and look at some proper examples, okay? Asymptotes are basically just equations of the lines that tells us which x and y values are off limits. They're super duper related to the domain, to the ranges. Like these super go hand in hand, which is why I put these all in the same video. But they kind of look a little bit different, or they're presented a little bit differently. And the IB is going to expect you to present them a little bit different to the domain and range so you can get off all those points when you're taking your exam. The important thing to know is that there's two types of asymptotes, which we're going to cover in detail, don't worry. The first one are the vertical asymptotes. These ones are basically just the same thing as the domain, or they're directly opposite to the domain. Which x values are not allowed? These ones are pretty simple to calculate or pretty simple to come up with. The horizontal asymptotes, the second one, are a little bit trickier, but these ones are related to the range. These ones are basically also the same question. Which y values are off limits? And the good question to ask yourself when you're trying to figure out what the horizontal asymptote for a function is what happens to the y values when x gets really big or really small, as in the or really big in the negative direction. Okay, let's go onto the notebook and do some examples.